So, nature is not random. It is remarkably, almost impossibly precise. Hi, my name is Minjoo Kim, and today we will talk about mathematics as a hidden script etched into every leaf, every galaxy, and every cosmos. Because math, it's not something that we just made up to measure the world. It's something that the world runs on. From the microscopic to the cosmic, mathematics is nature's silent architect. So today we will discover how mathematics is the hidden code of nature. And we will also delve into the origins of mathematics. So first, I want you to take a look at these four logos. If I were to tell you that all four of these share something in common, apart from the fact that they're all logos of very big, successful companies, what would you say? Well, the answer, surprisingly, or maybe unsurprisingly because my presentation is about mathematics, it lies all in math. Because math is about patterns, and all four of these logos follow a pattern called the golden ratio, or maybe more famously known as a Fibonacci sequence, which is closely linked to the golden ratio. So, you may wonder, why do these logos all specifically follow the golden ratio of 1 to 1.618? Well, companies use the golden ratio because it is believed to create visually pleasing designs that are naturally very appealing to the human eye. So us, as humans, are subconsciously more appealed to designs that seem to have this kind of a subtle balance. But that makes us now wonder and beg the question of, well, what is so special about this golden ratio that makes us as humans so attracted to it? And the answer lies in nature. Because the golden ratio is very prevalent in nature, whether you look at the spirals or the sunflower petals, or even many animals that display this kind of pattern. Because it is so prevalent, it affects our perception of beauty. And I want to give a very good example of how it affects our sense of beauty. Which is, you may all recognize that we all know how a lot of people believe that Cha Eun-woo has a very ideal face. And when we actually analyze his face, it turns out that his face almost perfectly matches the golden ratio. As you can see, the red lines almost perfectly aligns the guiding lines that follow the golden ratio. So this example shows us that subconsciously, we are more attracted to things that follow this pattern. And this is also the reason why artists like Leonardo da Vinci used the golden ratio in a lot of his artworks. His famous arts, such as Mona Lisa, or the girl with the pearl earring, also follows this golden ratio. And that is also the reason why a lot of artists actually recognized that the human body also, interestingly, follows the same pattern of a golden ratio. Well, you may wonder, then is this all? No, there's more. There's also golden ratio in architecture. And it was so prevalent that people in the 1500s called the golden ratio as a divine proportion and constructed architecture according to this rule as well. The famous example of Taj Mahal, or a lot of temples that were made in this Renaissance era, was also following this golden ratio. Now, we talked a lot about golden ratio, but there are also other patterns, not only including golden ratio, that is spotted in nature, such as fractals in the Romanesco broccoli, or various types of symmetry that is found in nature, such as the bilateral symmetry of a butterfly, a rotational symmetry of a spiderweb, and a modular symmetry of a honeycomb. And the reason for this is because nature prefers efficiency. And these patterns, these symmetries, are very efficient. But then this begs us a question. Well, if nature is so closely related to math, then is mathematics truly what we invented? Or did we just discover math to better understand the world? So I want to today talk about one of the first uses, early uses of mathematics in history that dates all the way back to at least 3000 BCE in the Indus civilization. As individuals started to own land, they wanted to ensure that their property is preserved. So at first, they just drew grids on land, as you can see at the very left image. But there was a problem. Water from the river washed away the markings. So each time they had to redraw the grids in order to show how much land they owned. So then they thought of an idea. So they got 4 pieces of rope and tried to hold it tight. But another challenge arose, which is that there are so many ways to hold the 4 pieces of rope tight. And just as you can see here in the 3 examples, they're using the exact same 4 pieces of rope, but they all have different area. So each time the area of land would change, and it wouldn't be guaranteed that they would have the same amount of area every time. So that's when they thought of a more clever idea, which is, now why don't we divide the ropes into 12 different parts by tying the knots? It might be quite hard to see, but they tied 12 segments and tried to mark that using knots. So they got 3 people, held it at 3 knots, 4 knots, and 5 knots. And this allowed them to guarantee that one of its angles is going to be a right angle, and use that to generate these kind of rectangular grids. 3 knots, 4 knots, and 5 knots. Sounds very familiar, right? It's the Pythagorean triplets. So even far before Pythagoras came up with the formal proof of his theorem using geometry, there was already an established understanding of right angles in earlier civilizations. And I want to give an example of Egyptians that used that similar kind of property to build pyramids. Because when they're constructing pyramids, they realized that the base of the pyramid had to be a perfect square in order for the pyramid to have a stable center of mass or stable center of gravity, so that it wouldn't tip over or fall over by accident. So they used the rope method, as we just talked about, to make the right angles of the squares at its base. As you can see here, many historians found pictorial diagrams of rope with knots that indicated the 12 equivalent segments. But exactly how the Egyptians constructed the huge pyramid still remains a mystery. But I'll introduce to you one widely accepted theory that is often known as the inset ramp theory. So first, they laid the white tiles down in a perfect square, except they left a small gap as shown in the image. After that, they filled up the entire layer with blocks, as you can see here. And after that, at the place where they left a small gap, they built a ramp. And for now, you might not really know why this is so useful, but it will become more useful as the construction goes on. So they repeat the process. They fill up another layer and increase the height of the ramp to match that layer. and they rinse and repeat this process. Now, as they go on, you can notice that the slope of the ramp will increase in a consistent manner. And when they reach a corner, they will make a turn and continue on the process. Now, once they reach the top, they lay down the final piece, also known as a pyramidion, which is often gold because they used to like gold a lot. And after that, all they have to do is come back down the ramp that they created previously. And when they're coming back down, they can fill it up using the tiles that they have. So this is an astonishingly mathematical example of how Egyptians could construct the pyramid at a very early time in history. But even earlier than that, math was still needed. And this is an Ishango bone that is often recorded as the first evidence of mathematics. And it dates all the way back to 20,000 BCE. So you may wonder, well, in 20,000 BCE, why would they even need numbers? How would they use numbers? Well, numbers were still needed to represent, for example, how many animals they hunted, or for transactional purposes such as exchanging food, exchanging goods, etc. So today we looked at a lot of examples of how mathematics was essential almost to human life. And I think one of the key reasons why mathematics is so crucial to our day-to-day life is because mathematical thinking is very closely linked to logic. Well, you may already know that most early mathematicians were actually also philosophers, like Immanuel Kant, Plato, René Descartes, and even Pythagoras. So, coming back to the question that I asked earlier about whether math is invented or discovered, I think that the best answer to that question is that we invented math as a language and as symbols to communicate the patterns that we discover in the universe. So in other words, we invented the questions, but discovered the answer to those questions. This summer, I was at a math camp for around 5 weeks. And on the last day, my professor asked me a question. Why do you do math? And why do you like math? And I think that this presentation today is my answer to that question. So, the next time you see a spiral, or the next time you stop to admire a flower, I hope you smile, knowing that the hidden code behind that was all mathematics. Thank you for listening.